I want to show you how to find the matrix exponential e to the at when given some matrix A. What we're going to do is we're going to find the eigenvalues of this matrix, which I've already done here, and find its corresponding eigenvector. So let's go ahead and start right there. I'm going to plug in 5 to the lambda subtracted matrix, so that's going to give me -4, 4, 3, -3. I'm going to augment this with a column of zeros, and then row reduce. I can divide this first row by -4, and it's going to give me 1, -1, 0, 0. And then I'm going to multiply this row by -3, adding it to this row, giving me 0, 0. The corresponding eigenvector I get from this is going to say x1 minus x2 equals 0, and if I let x2 be my free variable, letting that be 1, I get the corresponding eigenvector of 1, 1. Now if I do the same thing for lambda equals -2, if I plug -2 into the lambda subtracted matrix, I get 3, 4, 3, 4. Column augmented with zeros. Then I'm going to row reduce. I'm going to divide this first row by 3, giving me 1, 4/3, and I could have obviously subtracted this first row from the second row, getting me 0, 0 down below. This first equation reads x1 plus 4/3 x2 equals 0. If I let my x2 value be 1, my corresponding x1 value will be -4/3. Now because I don't like fractions too much, I'm going to go ahead and multiply this whole thing by 3, giving me an eigenvector of -4, 3. Now that I've got my eigenvectors, I can write my solution. That's going to be xvec equals c1 times the first eigenvector of 1, 1 times e to the 5t, since that was the corresponding eigenvalue, plus c2 times -4, 3 times e to the -2t, since that's the corresponding eigenvalue there. This is my solution. It's kind of like how we did this before. This is nothing too new. Hopefully we should all know how to do this process by now. But what I want to do is show you how to get this matrix exponential. So what I'm going to do first is create a matrix called chi. The chi matrix, chi of t, is taking each solution as a column in this matrix. So for instance, the first column of this chi matrix is 1, 1, but with the e to the 5t multiplied inside. So we'll say e to the 5t times 1, that will be e to the 5t. And e to the 5t times this one will also be e to the 5t. Now I'm going to say the next column is going to have e to the -2t times that vector, giving me -4 e to the -2t, and then e to the -2t times 3, that'd be 3 e to the -2t. Now this isn't my matrix exponential, this is merely the matrix chi, and I'm going to show you, I'm going to clean this up, and show you what you do once you have this chi matrix, what you do to find e to the at. Now the formula for finding e to the at is chi of t times chi inverse of 0. So we have that chi of t matrix that we had before, that's going to go here, but we need to find chi inverse of 0. So what I want to do first is plug in 0 for t. When I do that, I get chi of 0 equals e to the 0 is 1, e to the 0 is 1, e to the 0 is 1 here, but then I have a -4, and e to the 0 is also 1, but then I have times 3. So this is chi of 0, but I need to take the inverse of this matrix. So the inverse of a 2 by 2 uses this quick formula here. You swap the a and d values, so we'll say that chi inverse of 0 equals, swapping 1 and 3 gives me 3 and 1, and then we don't swap the off-diagonal elements, we just negate them. So -4 becomes +4, while +1 becomes -1, and then we have to make sure to multiply by 1 over the determinant out here. The determinant of this original matrix is 1 times 3 is 3, -4 times 1 is -4, so we have 3 minus -4, that will be 7, so I need a 1/7 out here, and I'm actually going to distribute the 1/7 to the inside of that parentheses, giving me chi inverse of 0 equals 3/7, 4/7, -1/7, 1/7. So this is my chi inverse of 0. I've got chi inverse of 0, I've got chi of t, so to find e to the at, I just take chi of t, which is this matrix here, and multiply by chi inverse of 0. It's really important that you do it in this order because order matters. So you have to do chi of t first. It's going to be e to the 5t, e to the 5t, -4 e to the -2t, and 3 e to the -2t. And I'm going to multiply it by my chi inverse matrix of 3/7, 4/7, -1/7, and 1/7. And now we're going to do the matrix multiplication. This is going to be, when I do the matrix multiplication, e to the 5t times 3/7 would be 3/7 e to the 5t. Now we got to keep going here because it's just this first row times this first column. I have to do this times this plus this times this. So I'm going to say plus -4 e to the -2t times -1/7. That's actually going to end up being plus 4/7 e to the -2t. Now I want to do the first column times the, first row rather, times the second column. So this is going to be 4/7 e to the 5t times, or rather plus, -4 times 1/7. So it's going to be minus 4/7 e to the -2t. I'm going to keep this going. Now I'm going to do bottom row times first column. I have e to the 5t times 3/7. That will be 3/7 e to the 5t. minus, or rather plus, but I'm going to have a minus here because of the negative. So plus 3 e to the negative 2t times negative 1/7. That'll be negative 3/7 e to the negative 2t. And lastly, I'm going to do e to this last row times this last column. E to the 5t times 4/7. That'd be 4/7 e to the 5t plus 3 e to the negative 2t times 1/7. So that'd be plus 3/7 e to the negative 2t. This matrix here is our answer. This is e to the at. Now it looks like a giant mess, but this is as simple as it gets. You really can't combine any terms here, but that is all the process you're going to use. You find chi of t, which is your fundamental solution matrix, putting your solutions as columns, plugging in 0, inverting that matrix, and then doing this matrix multiplication. Once you do that, this is e to the at. This process also works for a 3x3 case. It's obviously a little uglier because the inverse of a 3x3 is a lot uglier than trying to find the inverse of a 2x2. 2x2 has that quick formula in blue up here, which is nice, but in the case of a 3x3, I would have to do a little bit more work. Now suppose instead of being given a and trying to find e to the at, suppose you were given e to the at and tried to find a. Well, all you need to do to find a from e to the at is take the derivative of the matrix. So here we have e to the at. I'm going to take the derivative of this matrix, remembering chain rule is going to be at play here. Taking the derivative of 3/7 e to the 5t, that's going to be 15/7 e to the 5t. We have plus 4/7 e to the negative 2t. The derivative, that will be minus 8/7 e to the negative 2t. I'm going to keep taking the derivative all the way through. Okay, now that I've taken the derivative of this matrix, giving us this matrix here on the right, I'm going to plug in 0. So once I plug in 0, I should get the value of a. Remember that e to the 0 is 1, so a lot of this stuff's going to melt away. I'm going to be left with 15/7 minus 8/7. Well, that's just 7/7. I'm going to have 20/7 plus 8/7, that's 28/7. 15/7 plus 6/7 is 21/7, and 20/7 minus 6/7 is 14/7. Now, of course, I can do the division here. 7 divided by 7 is 1, 28 by 7 is 4, 21 by 7 is 3, and 14 by 7 is 2. But hey, check it out. 1, 4, 3, 2 is the exact same matrix that I started with up here. This is the matrix that I used to create the exponential matrix here. And of course, if I want to go back from the exponential matrix back to a, I take the derivative, then plug in 0, and once I do, this is my matrix A.